Welcome back to the HEINS Potential Difference YouTube channel. In this demonstration today, we're going to be introducing the load current delay and how that contributes the ReGenX generator coil's load current delay and how that contributes to infinite generator efficiency. And we're also going to be introducing HEINS' law of induction, which is the reversal of LENZ'S law of induction. So what we're going to be doing is we're going to be running this prototype. And this prototype is unique in that it has two coils. It has a conventional generator coil, and which will establish the blue load current sine wave on the oscilloscope. And then we have a ReGenX coil that is in the inside. This is an E-core design, so the conventional coil is wound around the outside, and the ReGenX coil is embedded inside in the middle finger of the E-core. And what we'll be looking at is the load current sine wave for the conventional coil, the balloon sine wave, and the load current sine wave for the ReGenX coil. And we will analyze what's happening in the ReGenX coil that contributes to infinite efficiency operation of the generator. So the conventional coil is connected to a load, and the ReGenX coil is connected to an identical load. The conventional coil delivers usable power to the light bulb and the electromagnetic field energy that's created around the conventional coil will perform negative work, and it will reduce the kinetic energy of the system. And the ReGenX coil, the electromagnetic field energy that's created around the ReGenX coil, will perform positive work, and it will increase the kinetic energy of the system. In addition, the magnetic field energy that's created around the ReGenX coil will also be collected into the core of the conventional coil, and that is the term we call flux harvesting. And that increases the output across the load. So the electromagnetic field energy that's created around the ReGenX coil performs two types of work. Number one, it performs mechanical work, increasing the kinetic energy of the system. And it performs electrical work, increasing the output across our load. So in our speed versus torque and current and horsepower graph, I have included the power consumption curve for the induction motor that we're using as our prime mover. So what we will notice as we start our induction motor prime mover, the power consumption of the motor will be very high. And as the system gains speed, the power will drop towards zero. It won't reach zero, but it will approach zero. Now, understanding this graph is important because if And what we're going to do again is we're going to bring our system up to rotational equilibrium. We always start our demos there. So rotational equilibrium means that the net torque in the drive shaft is 0, and the net power, or the power that's in the drive shaft, is also 0. So if the consumption of the prime mover goes up, that means that the system is decelerating. That means that some force is reducing the kinetic energy of the system. And what's going on is the magnetic field energy that's created around the conventional coil is performing negative work, and it's decelerating our system. If this number goes down, that means that the speed is increasing, and that also means that some external force is accelerating or increasing the kinetic energy of the system. And the force, or the energy that's performing the positive work, accelerating the system, is the electromagnetic field energy that is created around the ReGenX coil. So let's do some basics with regards to a sine wave, a load current sine wave. So here we have let's say the load current sine wave for the conventional coil that's in our system. And the most bottom part of the sine wave is called the trough. The peak of the sine wave is called the crest. And where the sine wave crosses the 0 mark, that's called the node. Now, as the load current increases, what that means is, and it's important to understand, is that, actually I'll do it with this one. As the load current is increasing, that means that we have a North Pole magnet that is approaching the coil. And as the magnet gets closer and closer and closer until it reaches top dead center, the current in the coil increases. And the induced electromagnetic B field, it's called the B field, it produces a magnetic field around the coil. Here we have it here. It produces a magnetic field around the coil which performs negative work and resists the magnet's approach. Now, I'm correcting a mistake that I have been repeating now since 2007. And what I've been previously saying is when the rotor magnet moves away, the current changes direction. When the North Pole magnet moves away, the current doesn't change direction. The current doesn't change direction until it goes on the other side of the node as it goes down. What's really happening is the North Pole magnet is moving away from the coil. Here, it's moving away, but the induced B field in the coil is now a South Pole. A North Pole magnet that approaches a coil induces a North Pole repelling magnetic field which resists the magnet's approach. When the North Pole magnet moves away, the induced B field produces a south pole which resists the magnet's departure. So the magnetic field that's created around the coil is always resisting the rotor magnet's approach and its departure. So again, as the magnet approaches, the magnetic field strength increases, the induced voltage and current in the coil increases, and when it starts to move away, the current decreases. So the current doesn't change direction until the south pole magnet starts to approach the coil. So let's look at what the load current sine wave looks like. So here we have the load current, the delayed load current sine wave for the ReGenX coil, and you're going to see that in a second when I operate the prototype. And from here to here, again, it's important to understand that the conventional load current sine wave establishes the relative position of the rotor magnet as it's approaching the coil. So we have a rotor magnet that is approaching the coil's core at top dead center, and the load current sine wave for the ReGenX coil, it doesn't peak, it doesn't max out or crest until the rotor magnet has already moved away. So as the rotor magnet starts to move away from the coil's core, the induced B field in the ReGenX coil is still producing a north pole magnetic field from here to here, which has the effect of accelerating and increasing and performing positive work on the rotor magnet that is now moving away. So if we look at HEINS' law of induction, and we focus our attention primarily on the north pole magnet that is approaching the coil. When the north pole magnet is approaching the coil, the load current delay in the ReGenX coil is producing a south pole, which is assisting the magnet's approach. When the north pole magnet is moving away from the coil's core, the ReGenX coil is producing a north pole which is assisting its departure, and the south pole is being assisted in its approach by this magnetic field and assisted in its departure by this induced magnetic field as well. So in the conventional generator operation, the induced electromagnetic field energy is always performing negative work. It's always producing a counter electromagnetic torque. It's always producing electric vehicle regenerative braking, if you want to call it that. And in the ReGenX coil, the created electromagnetic field energy that's produced around the ReGenX coil is the net effect is that it produces positive work with electromagnetic field energy that's created and electric vehicle regenerative acceleration. So we'll fire up our prototype and we'll take a look at LENZ'S law, less than 100% efficiency, and we will look at HEINS' law of induction and infinite efficiency of operation. Okay. We're at rotational equilibrium. And now we'll look at the load current sine wave for the conventional coil in the prototype. So when we place our conventional generator coil on load, you will notice that the input power to the prime mover goes up, and we will hear the speed of the system go down, which means that we are heading in this direction on our curve. And when we put the ReGenX coil on load, well, let's just do that again. Now our prime mover is consuming additional power, the speed is going down, and the generator is delivering power to the load according to LENZ'S law of induction. The magnetic field energy that's created around the conventional coil is performing negative work and reducing the kinetic energy of the system. So now we'll let's put it on no load again so we can confirm where we're starting from. Watts to our prime mover. consumption to the prime mover while generating electric output power. And we can see the load current sine wave for the ReGenX coil, which is delayed in the time domain. This line down the center denotes top dead center, and we can see that the ReGenX coil is the induced magnetic field energy around the ReGenX coil is producing a north pole magnetic field when the north pole magnet is moving away from the coil's core. So LENZ'S law, Newton's third law, law of conservation of energy. If you ignore the negative work performed by the created electromagnetic field around the condenser coil, less than 100% efficiency of operation. And HEINS' law, no increase in the consumption to the prime mover, which means no increase in the mechanical power of the drive shaft, and which means electromagnetic assistance, positive work being performed with created electromagnetic field energy. So previous video, I explained how LENZ'S law proves the law of creation of energy, and how LENZ'S law invalidates the law of conservation of energy, which says that energy cannot be created or destroyed. And LENZ'S law proves that energy can be created because the energy that's created in an electric generator is performing negative work, and it's reducing the kinetic energy of the system according to the work energy principle. And HEINS' law uses this exact same created electromagnetic field energy, and it delays it in the time domain And it uses that same created electromagnetic field energy to perform positive work at infinite efficiency, and reaffirming the law of creation of energy, which was originally discovered in 1820 by Dutch physicist Hans Christian Ørsted, who is still waiting for his credit. So, thank you for taking the time to watch this video, and cheers.